Welcome. In this lesson, we're covering the fundamentals, types, variables, and input-output. These are the building blocks of every C++ program. By the end, you'll understand how data is stored in memory, how to initialize variables correctly, how to read input from the user, and how to print formatted output. If you've set up your compiler and IDE from the previous lessons, you're ready. Let's build the mental model first, then write real code. A variable is a named piece of memory that holds a value. In C++, every variable has a type that determines what kind of data it stores and how much memory it uses. Here are the 5 types you'll use most as a beginner. Int, for whole numbers. Int count equals 3. Double, for decimal numbers. Double price equals 9.99. Bool, for true or false values. Bool ready equals true. Char, for a single character. Char grade equals capital A. And std string, for text. Std string name equals ADA. Notice that every declaration follows the same pattern. Type, name, equals, value. The type tells the compiler what operations are valid. You can add integers, compare booleans, and concatenate strings. But you can't add a string to an integer without an explicit conversion. C++ gives you several ways to initialize a variable, but one style stands out for beginners. Brace initialization. Instead of int age equals 42, write int age, open brace, 42, close brace. Instead of double ratio equals 0.5, write double ratio, open brace, 0.5, close brace. Why prefer braces? Because brace initialization catches narrowing conversions at compile time. If you accidentally try to store a double in an int using braces, the compiler will warn you. With the equal sign, it silently truncates. This is a small habit that prevents real bugs. Use braces when practical, especially for numeric types. To print values to the screen, you use std_cout with the insertion operator, the double less than sign. You can chain multiple values in one statement. For example, std_cout, shift left, name, shift left. The string has age, shift left, age, shift left, \n. Each shift left operator sends the next value to the output stream. The \n at the end adds a new line. You can chain as many values as you need: strings, numbers, variables, expressions. The compiler figures out how to print each type automatically. This is how most C++ programs produce output. Sin and the string variable as arguments. Getline reads the entire line, including spaces. Use it when you need full-line text input, such as a person's full name or a sentence. The rule of thumb is simple. Use the extraction operator for numbers and single tokens. Use getline for text that might contain spaces. Let's combine everything into one small program. We include IOStream and string. In main, we declare a string called name and an int called age, both initialized with empty braces. We prompt the user with cout, then read their name using getline. We prompt again for age, then read it with sin and the extraction operator. Finally, we print the result. The name, followed by the words will be, followed by age +1, followed by the words next year. This program brings together 4 ideas: string input with getline, numeric input with sin, arithmetic by adding 1 to age, and formatted output by chaining multiple values. Pay attention to the order. We read the name first with getline, then age with sin. That ordering matters, and we will explore why shortly. Here's a habit that separates careful programmers from everyone else. Always validate input before using it. Stream extraction can fail. The user might type hello when you expected a number. There might be an overflow, or a previous stream error might still be active. The pattern is simple. After reading with sin, check whether the stream is still in a good state. If not, print an error and exit. The code looks like this. If not, open parenthesis, std sin, shift right, age, close parenthesis. Then print an error to CEER and return 1. The exclamation point before the parenthesized extraction checks the stream state. If extraction failed, the condition is true. Get into this habit now. In real programs, unchecked input is one of the most common sources of bugs and security vulnerabilities. This is the most common beginner input bug in C++. Here's what happens. When you read a number using the extraction operator, it takes the digits, but leaves a new line character sitting in the input buffer. If you then call getline, it reads that leftover new line immediately and gives you an empty string. The fix is simple. After reading the number, call ignore on the input stream. This clears the leftover new line from the buffer. Then, getline works correctly. The pattern looks like this. First, read the number. Then call ignore to clear the buffer. Then call getline to read the text. Without that ignore call in the middle, your text variable would be empty. This catches almost every beginner off guard. Now you know the fix, and you won't forget it. 2 keywords that make your code cleaner: const and auto. Use const by default for any value that shouldn't change after initialization. Const auto max retries equals 3. The compiler enforces this. If you accidentally try to modify max retries later, you get a compile error. That's a safety net, not a restriction. Use auto when the initializer already makes the type obvious. Auto price equals 19.99. The compiler deduces that price is a double from the literal. You don't need to write double explicitly. The combination of const and auto reduces noise in your code while making intent clearer. Const says this value is fixed. Auto says the type is obvious from context. Use both liberally. 2 practical skills you'll need almost immediately. First, numeric conversion. When you assign a double to an int, the fractional part is dropped. Double price equals 9.99. Int whole equals static cast int price. The static cast makes the conversion explicit. You're telling the compiler and anyone reading the code that you intend to lose precision. Never rely on implicit narrowing conversions. Second, output formatting. By default, cout prints doubles with up to 6 significant digits, which can look messy. To control decimal places, use the fixed and set precision manipulators from the io_manip header. std cout, shift left, std fixed, shift left, std set precision 2, shift left, price. This prints 9.99, exactly 2 decimal places. Use this for prices, percentages, or any output where formatting matters. Let's put everything together in one program that uses all the patterns we've covered. We read a quantity as an integer, validate it. We read a price as a double, validate it. We call sin.ignore to clear the new line buffer. Then we read a label with getno for full line text. Finally, we print the result with fixed precision formatting. This single program combines numeric input with validation, the sin-ignore pattern for mixing extraction and text input, and formatted output with 2 decimal places. If you can write this program from scratch and understand every line, you've internalized the core I/O patterns in C++. Try modifying it. Add a total calculation, add a second item, or handle the case where the user enters 0. Before moving on, internalize this 4-step pattern for beginner programs. Step 1. Read input. Step 2. Check stream state. Step 3. Compute. Step 4. Print clearly formatted output. This habit scales much better than reading everything first and only checking errors after the fact. Validate early, fail fast, and keep your output clean. For next topics, continue with control flow and functions to learn conditionals, loops, and how to organize code into reusable pieces. Then, build and debug to deepen your understanding of the compilation pipeline and debugging workflow. The IDE helps you work faster, but the language fundamentals we covered today, types, initialization, input, output, validation, these are what you'll use in every program you write. Thank you.